Writing rational expressions in lowest terms. So say, for example, I'm given 3a squared minus 7a plus 2 all over a squared plus 2a minus 8. So the first thing we need to do is factor the top and the bottom. Well, to factor the top, we get 3a squared minus 6a minus a plus 2, group in sets of 2. Same step in the bottom, we have a squared plus 4a minus 2a minus 8. Pulling out what's common out of the top term, we get 3a, so we get a minus 2. Pulling out a negative 1, we get a minus 2. Doing that same step to our bottom, we pull out an a out of the first one and get a plus 4. Pull a negative 2 out and we get a plus 4. So what's in parentheses in common in the front is a plus 2. What we pulled out front is 3a minus 1. What's in common in the bottom is a plus 4. What we pulled out front is a minus 2. Notice top and bottom, they share this in common. So they cancel, leaving me with 3a minus 1, a plus 4. And that would be written in lowest terms. What if I'm given t cubed plus 8 all over t plus 2? The top is a sum of cubes, so we can rewrite it to be 2 cubed plus, or t cubed plus 2 cubed over t plus 2. So factoring the top, we get t plus 2, t squared minus 2t plus 4, all over, bottom stays the same. They share this in common. So I get t squared minus 2t plus 4. am minus bm plus an minus bn all over am plus bm plus an plus bn. We have 4 terms in both the top and the bottom. So I'm going to group in pairs in both the top and the bottom. On the top, they have an m in common, so I get a minus b. Plus an n in common, a minus b. On the bottom, I share an m in common, so I have a plus b. And an n in common, a plus b. A natural tendency at this point would be to cancel here. You can't. Because of this plus, it has to come out of all 4 terms. But I can continue to factor. Because they share a common of a minus b, that's one term, and what I pulled out front is the other. What I have inside is one term, and what I pulled out front is the other. Now that there are things being multiplied without this addition in between, I can cancel. So I get a minus b all over a plus b. Another option is, what if I'm given a minus 10 all over 10 minus a, and I notice, well, they'd be the same if something was flipped. So what I can actually do, keeping the top the same, I could factor a negative 1 out of the bottom and get a minus 10. They'd both switch signs. So instead of a negative a, instead of a 10, negative 10. Because when this negative comes through, you would times and become that again. Well, they have this in common. So 1, a placeholder for the top, divided by negative 1, what's left on the bottom, and I get a final answer of negative 1. Doing one last example. Let's say, for example, so that was number 4, so this is number 5. that I was given 81 minus y squared over y minus 9. Well, on top, notice it can be rewritten to be 9 squared minus y squared. Bottom stays the same. So top factors to be 9 minus y, 9 plus y, over y minus 9. Well, notice these are just the reverse of each other. They're the flip. So on top, what I can do is pull out a negative, and it becomes y minus 9. But the second one is not affected by that. The bottom stays the same. Now they cancel, so I get negative 1 times 9 plus y, or distributing that through, I get negative 9 minus y. Either would be a perfectly acceptable answer. You could also put negative y minus 9 by flipping them and writing them in a different order.